In this session, we are going to discuss about the centroid of the T-section. So here is the question. Determine the centroid of the given T-section. So here, the width and depth of this section is given. First step what we need to do here is, we need to draw the reference axis. So here you can observe the reference x-axis and the reference y-axis. So in the second step, what we need to do here is, we need to divide the given figure into simple geometrical shapes and name them as 1 and 2. So if you observe here, we can divide this T section into two small rectangles and consider them as section 1 and section 2. Next, what we need to do is, we need to determine the areas of the simple sections. So area of the first section, let us say it is A1, which can be taken as B1 into D1. So here you can consider this as B1 and this one is D1. So 120 into 20. So here all the dimensions that are given are in mm. So we can take this as 2400 mm square. Then area of the second section is B2 into D2. Here B2 is 20 and D2 we can consider it as 100. So 20 into 100, this will be 2000 mm square. So now in the step 3 we have determined the areas of these simple sections. Let us go for locating the centroid of each section with respect to the reference axis. So with respect to reference axis means, as we have named these as x and y axis. So we need to locate the centroid of the given sections with respect to the reference axis. That means, so from this y axis, the distance at which this centroid is located will be x1, and from the x axis, this distance we need to consider it as y1. Now g1 x1 comma y1. So x1 will be half of this 120. So 120 by 2 comma y1 will be half of this section 20. So 20 by 2 plus we need to consider this distance from the reference axis. So we need to add this 100 also to the value of y1. So from this you will get 60 comma 110 as the value of g1 x1 comma y1. Now g2 x2 comma y2 we need to determine. So x2 is this distance, the distance from the y axis, and again x2 will be 120 by 2 only, because we need to consider the distance from the reference axis, not from the distance from this edge. So 120 by 2 comma, and this height is y2. So this will be half of 100. So from this you will have 60 comma 50. So here we have located the centroid of each section with respect to the reference axis. Now we need to determine the centroid of this total figure. So to determine the centroid of this total figure, we need to use the formulas x bar is equal to a1 x1 plus a2 x2 by a1 plus a2, and y bar is a1 y1 plus a2 y2 by a1 plus a2. So here area of the first section we have got 2400 multiplied by x1 is 60 plus a2 value is 2000 multiplied by 60 divided by 2400 plus 2000. So here we are going to get the value as 60 mm. So x bar is 60 mm. Now similarly we need to determine y bar. So y bar is a1 y1 plus a2 y2 by a1 plus a2. So a1 is 2400 multiplied by y1. y1 value is 110. This is what we have obtained, plus a2 value is 2000 multiplied by y2 is 50 divided by a1 plus a2 is 2400 plus 2000. So from this we will get the value as 82.73 mm. 82.73 mm. So this is the centroid that we have obtained, x bar and y bar. Now we need to locate the centroid, total centroid. So in order to locate the total centroid, so first of all we have got x bar as 60 mm. So as x bar is 60 mm, so if I draw a line like this, this line is at a distance of 60 mm from this y-axis. So from the y-axis the location is 60 mm. So x bar is 60 and y bar we have got 82.73 mm. So that means from the x-axis the distance is 82.73. If you observe carefully, so this G2, this value that we have obtained is 50 and here this D2 value is 100 what we have got. So 82.73 will be somewhere in between this 50 and 100. So we can keep it like this. This is G and this distance we can consider it as y bar, that is 82.73 mm. This is how we need to determine the centroid of the given T section.